Okay, so this is the output of the hierarchical multiple regression. As usual, we have been given information about the descriptives and all those things. We can look at this dialog box here and look at what we have to look out for. So the first thing that we go through is what we call model summary. Have you seen? So click on that, and our model summary results will come. We copy it and paste it on a Word file.
Models.
So we have copied it and we have put it on this Word file. That is the model summary of the analysis that we did. Now, whenever you do regression, there are some key factors that you have to consider in your model summary table. But since we entered the variables in 2 steps, it will give us the first model and then also give us the second model. So the first model, the only predictor that we consider was the firm size.
So the model here is the block 1 and block 2.
Yeah. So we have model number, have you seen?
Yeah.
This is the model.
So the first one was the firm size.
So the first one is for the firm size. Look at the predictors. Predictors A. It's talking about what? Constant and firm size, right?
Yes.
So that is for those here. So let me make it red. So that is for the first model. When we enter firm size alone into our model, what happened? But before we assess this one, we have to come and assess this what we call autocorrelation. W Watson is used to check autocorrelation. And W Watson.
Okay, the last one.
Yeah, W Watson. You can't see it, eh? It's the one at the corner there. W Watson. It must fall within what range? This range is between 1.5 and 2.5. If the score that you get for W Watson is within that range, we conclude that there is no threat of serial or autocorrelation.
So is it negative or positive?
That one is absolute. 1.5 to 2.5. So let's take a look at it. The W Watson is 1.941. Does this fall within that threshold?
I think with the firm size, it didn't give a figure for.
Yeah, this is for the entire model.
Oh, okay.
Not for model 1.
Okay.
Separate from model 2. This is for the entire model. So if you look at it carefully, you see that it's 1.941, which falls within that range of 1.5 and 2.5. So we can conclude that there is no auto or serial correlation in the model. After that, we come and look out for what we call the R. And the R measures what we call the joint correlation. The R measures the joint correlation. Joint correlation. This correlation is the relationship between the predictors on one hand as against the dependent variable.
Okay.
Did you hear that?
Yeah.
I said it's the relationship between the predictors, between all the predictors on one hand, okay, and then the dependent variable on the other hand. So if you look at it for correlation, we can get positive correlation or negative correlation. Is that not it? We can get positive correlation or negative correlation. When we get negative correlation for the joint, it means that the factors are reducing the dependent variable. Okay? When we get negative, what did I say? It means that the predictors are what? Reducing the dependent variable, or are likely to reduce the dependent variable. When you get positive, it rather means that they are improving the dependent variable. It means that the predictors are improving the dependent variable. If we look at model 1, what predictor are we talking about? For model 1, what predictor are you talking about?
We are talking about the firm size.
Yeah. So together with constants, they relate with this one by this margin, which is positive and it is a small relationship. Then R square measures how much change in the dependent variable is caused by the predictors. Okay? How much change in the dependent variable is caused by the predictors. So the R square, we normally express it as percentage. So we multiply it by what? By 100. Okay. So in this scenario, firm size alone can account for how much change in profitability.
3.6%.
That is adjusted.
Firm
I'm
size.
talking about the R square.
Okay, that is 40%. 4%.
4%. So firm size alone, given its constant, can account for 4%. Okay. Now, is this contribution significant or not? Go to the significance F change.
It's significant.
Is it significant or not?
Significant.
Significant because less than good. So that is how we interpret the first block. Let's go to the second block. The second block, look at the predictors. Constant and what? Constant and what?
Constant and the other variables.
No. The second block. I'm talking about block. This block. What are the predictors?
The predictor is.
The predictors are the B for the B. What are the predictors?
Supply chain.
No. I'm drawing your attention on this. You see that in the model B, farm size has still been what? Included.
Yes.
That is what I want to draw your attention on. When it is standing alone, how much did it cost? And when it's also included, let's see how it's going to behave.
Okay.
Okay.
So now we are trying to control.
Yes.
The control for dollar.
Yeah. So firm size is part, and then the other aspects of the supplier integration that we got selected. Those are the things here. And look at the R square change. The R square change is what?
The model 1.
With the model 1,
0.040.
and then with the model 2, how much change?
0.321.
Okay. So firm size alone will account for this. When we add all this thing, including the after control for firm size, we are getting 32.1%. For firm size alone accounted for 4%, but firm size together with the supplier integration things, when you put them together, we are accounting for how much? 32.1%. When you add that change to the first one, you should be able to get the change here. You should be able to get the R square. You should be able to get this R square, okay? So you can check this one. 0.040 plus 0.321. You should be able to get this figure.
Yeah.
0.361.
I thought you were adding.
Yeah, I had 0.361.
Okay, 0.361.
Yes.
No, it should be 0.
Because this is 4 instead of the 4 zeros, that's it. But this 0.321.
Okay.
Yeah, then it's okay.
So it's almost the same, right?
Yeah, it's 0.001.
So that is the interpretation. We can also give the interpretation to the R, the joint correlation here. We can also give the same interpretation as the relationship between all the predictors on one hand and then the probability. Yes.
With the fact when you control for fence size, meaning that's how you interpret it. You should make sure that when you add the R square change of the fence size alone and then the control one, you should.
Don't worry, I'm giving you some clue. Check that one. We are going to use it to make a decision. When frame size alone is there, how much are we getting? And when frame size is controlled for, how much are we getting? You see that the R square change is lesser than the R square. Is that not it? Which means that if you don't control for the frame size, we may overestimate. We may overestimate what?
The ability of the predictors
To predict the change. You will see that it's 36.2. But the actual thing is what? 32 what?
points.
0.1.
That's the change.
That's the R square change.
When you introduce the other variable.
Okay. When you control for fence size.
Yeah, well, so if you control for, this is how much we are going to get from. So it means that frame size is something that influences the behavior of the R square. Okay. Now let's go to the second aspect of the model. We have to come and check if it is significant or not. And the ANOVA is the one that we normally use. If the model is significant or not. So if you look at for model 1, the sig value is what? Which is the same as p value. Is it significant or not significant? Yes. It's significant, right? If you look at model 2, is it significant or not significant? Yes. It is significant. Okay. That's all. So let's go to the contributions. The contributions. Yesterday we were not here, so we will not as well get it as much as this month.
You trying to separate it.
The contributions. We see that all the predictors, after controlling for frame size, they accounted for 36.2%. That's not it.
Yes.
And the model is significant. The ANOVA is, if the ANOVA is significant, it means that at least one of the predictors is making significant contribution to that 36.2% that we got out there. So once it is significant, you see, once this is significant here, we conclude that at least one of these predictors is also making significant predictions in causing that 36.2 change in the R square, or in the profit.
Either the fence size or the.
Very good. So we come and look at for which is causing that.
Okay.
And that we get it from what we call the ANOVA table. Sorry, we get it from the coefficient table. coefficient table. Coefficient table. So we copy the coefficient table and place it there. Put the coefficient table and place it there. Let's go to our showing the
coefficient table.
Sorry, this is the edited coefficient table showing the contribution of each of the predictors. So, as usual, we have two types of things to consider. We consider the standardized beta coefficient for purposes of comparison. Then, we also consider the unstandardized beta coefficients to estimate the regression function. To estimate the regression function. To estimate the regression function. So we use the standardized beta coefficient. Standardized beta coefficient for comparison purposes. To know which of the predictors is making the highest significant but unique contribution to predicting the change in profitability. So let's evaluate for the first one. The first model is constant between constant and farm size. If you look at the unstandardized, the constant is making some predictions. Is that not it? This is it. Is it significant or not significant?
It's significant.
It's significant. So it means that apart from firm size, there are other factors that contribute to profits or profitability that have not been captured by the model. And those factors will roughly account for that. That is the meaning.
Okay.
So that's for the standardized.
No, that is for the constant.
Okay.
You know, when we are selecting the model, or when we are selecting the variable, did we select anything called constant? So how come constant has come? It tells you that even if you don't consider frame size, there are so many other things that can also influence. And those things can contribute 3.904, and their contribution is significant.
Oh, okay. So this doesn't mean that firm size is contributing this.
Yeah.
Okay.
Now, before you now go and look at for what firm size is contributing. So if you look at this beta on standardized, firm size contribution is what?
Negative 0.662.
Is it significant?
Yeah.
So what does it mean? It means that
Firm size is contributing.
is it increasing the profitability or reducing it?
Negative.
Yes.
So that reduces the profitability.
The firm size reduces the profitability.
So though it's significant, but it's reducing.
Yeah, because it is negative. So that is for the first model.
But why the firm size? Why are we not using the negative 20.201? That on the standardized coefficient.
We can use but now you are not comparing with anybody.
Okay, because
it is in the second model that we can compare this contribution with other predictors.
Okay.
If we had control for more than one factor, like maybe firm size, firm age, then we have also looked at the issue so that we can compare between firm size and age.
Okay.
But here we only have one, so we cannot compare it.
So you mean that one cannot compare with these ones?
Yes. The way we can compare them is here. Okay, the second model. Remember, the first model is only for firm size.
Yes.
And then the second model is the firm size, after control for the firm size. And then all the other factors as well. So we now come and evaluate the second model. So the same thing, look at the constants. Is it significant?
Yes.
Let me make it red.
0.00.
0, 0.
Yes.
So it says that apart from the predictors that we have selected, there are other factors that can cause for changes in our profitability that are not captured in our model. And it is true, we can't say that all the things that the businesses are doing, supply integration is the one causing them to make profit.
No.
There are so many other factors that can improve the profit making, but that are ignored in the model.
So with the first one, that is you just looking at only fence size. But the second one, that is when you control for fence size. Okay.
Or when firm size interact with other factors, let's put it that way, okay? When firm size interact with other factors, what is this contribution? So when we mingle firm size with others, look at this carefully. What becomes of the contribution of firm size? When it is lumped with the other factors, when it is controlled for, what becomes its contribution? Negative 0.080. Can't you see that when it comes to interact with all these things in a single model, the contribution has reduced from negative 2 to what? What are the details?
When the other factors come, they come to reduce the negative contribution of the firm size.
Very good. In other words, firm size also influence the way they also behave. Because firm size alone is making a contribution with negative, it is reducing profit by 0.2262 as a single model factor is there. But when we integrate it with all other factors, now its reduction in profit has reduced to 0.080.
Okay.
And is it significant or not significant?
It's not significant.
Are you sure? Very good. Very good. You see that it is not what? Significant. So if you are doing this analysis and you don't consider firm size, you will make a big mistake. If you don't control for firm size, you overestimate that, the factors account for 36.2. But when you check the R square change, when you control for firm size, it moved from 0.3 something to, this is what I'm talking about. It moved from 0.4 to what? 0.321. So in other words, when we are doing supplier integration, we have to consider firm size. In other words, it's not every firm that you can integrate them to do business with. You have to look at whether it is a small, micro, medium, or large firm before you take a decision. In fact, this analysis that we are doing, before you can control for the effect of any factor, it should be informed by theory. But this is just for purpose of illustration. So if the interpretation is not opening up to you, don't be worried, because it is my area of study. So that's why I'm able to understand it this way. Okay. So at least this indicates that for the contributions in the first model, it was reducing profit massively. Now when we integrate it with the other factors, it is reducing profit all right, but it is not what? significant. So it means that we have to consider firm size before we integrate with any other business. If they are suppliers, we really have to consider their size. Okay. Now, we can now look at the contributions of the other predictors. So if you look at, we synchronize business activities with those of key suppliers. Is it improving profits? Look at the contribution. 150, right? Is it significant?
Yeah.
It's significant. It's significant. So if this, and it is positive, right?
Yeah.
If it is positive, what does this signal? What does it signal? It is increasing the profit that the business is what make, because the dependent variable is profit. So it is increasing the profitability. Let's look at the second one. We constantly explore new working relationship with suppliers. Look at its contribution. Negative 0.0, so negative 0.010. It's not significant, right? So what does it mean?
It reduces profit, but that is not significant.
That is not significant. It means that we got the result by what? Chance. Okay. So will you go on constantly exploring new relationship with suppliers? If you want to increase your profit, will you do that?
Reduces profit.
It reduces profit and it's also not significant. So it is a waste of resource. Tell management to stop doing that. Let's go to the next one. The next one. We pursue supply interrelationship and involvement that go beyond operational transactions. What is the contribution? Is it improving or is it significant or not significant? So what does it mean?
It reduces profits.
Yes.
The reduction is significant.
Okay. And therefore we didn't get the result by chance. In fact, if they keep on trying to develop relationship that go beyond operational kind of thing, it is not helping them to make profit. Because businesses spend money to build relationship, right?
Yeah.
You support them, you train their workers, you visit them, and blah blah blah. They all go with consumption of income. Is that not it? You do all those things that are beyond operational activity.
Even at a point when they are not giving you what you want, but you still try.
So that will cost you. So this is rather having potential, actually reducing the profit level of the firm. Okay. So, and the other host of results are presented. Okay. So that is the interpretation we give. So here, for you to really appreciate it, the first point of call that you have to look out for is the model 1. Model 1, you look at the R square, and then the the R square will change. Then for the model 2, you look at the R square and also the R square will change to see if it is controlled for how the R square will be, and if it is standing alone, how the R square will be. Then you come and evaluate if the model is significant or not by looking at the ANOVA. As soon as the ANOVA portrays to be significant, it tells you that at least one of the predictors is significantly contributing to the change. As measured by, the change is measured by the R square. So at least one of the predictors is making significant contribution to that R square. Then you come and ask yourself, where lies the contributions? And again, you look at the first model, look at the contribution of the firm size, and you take a critical look at it, look at the figure, and look at the significant level. Then when it is controlled for in the second model, you look at its contribution as well. So that you can compare that, then firm size really having impact on When does it really interact well when it is controlled for with the other factors, or it doesn't behave well? So that is that. Any question?